All right, we have quite a few on, so it might get started. Hello, everyone. Thanks again for joining us today for our latest HashiCorp snapshot titled Terraform and Serverless Framework Working Together, which will be presented by Solutions Engineer Dan Kirkwood. So Dan is going to talk about how Terraform can play an important role or part in your serverless compute storage pipeline. He's going to go through some slides, and he's got a great demo that he'll take you through as well. I would like to note that this session is being recorded, and we'll make the recording available in a day or two once we've gone through processing, and I'll be sending out an email with a link to that video. So today's demo will last for about 15 minutes, and to keep it to the 15-minute time frame, we may not have time for questions, but please do feel free to add any questions you might have into the chat or the Q&A tab. And we've got some engineers online to help answer those questions as we go. So with that, let's go ahead and get started. Over to you, Dan.
Awesome. Thank you, Pete. Hello, everyone. I assume everyone can hear me. Give me a quick thumbs up.
Yep, we can hear you.
Yeah, awesome. Hi, everyone. Welcome to Terraform and Serverless, or as I like to call it, infrastructure as code without the infrastructure. As Pete mentioned, I'm Dan Kirkwood. I'm based in Sydney, Australia. And really looking forward to spending the next 15 or so minutes with you all. Here is basically what we're going to cover. It's all pretty straightforward. I'd like to get through the slides as quick as we can and jump into a demo to hopefully make this a little bit real for you today. Okay, but before we get started, I kind of want to talk about serverless and what is serverless? And I think similar to how we saw the definition of cloud change over the years, this is a term that was maybe sort of clearer and more defined a few years ago, but is now entering what I see as a bit of a muddier state. I really think the aim of serverless is to allow a developer or a business the ability to release their application with as little friction as possible, ideally without having to think about infrastructure. This is something that we've had somewhat with platform as a service providers to a degree. But if we think about 2015, AWS launches Lambda, and then kind of they take this idea of code without infrastructure and push it to an extreme, right? And that extreme is I'm able to take my code, scale it from 0 up to a very, very large amount of consumption. I'm able to spin it up extremely quickly. And kind of the trade-off there for the developer compared to platform as a service is maybe they get a little bit less control around the environment that exists around that code. The other major clouds followed suit in the next few years. And now if we think about function as a service, and I think a lot of people really see that as the core offering that's part of serverless, you have a wide range of platforms to use for function as a service. What I've seen over the past few years is a proliferation in other serverless technologies, which I'd categorize as cloud native. Okay, so think about something like Google App Engine or AWS Fargate. They're kind of aimed at harmonizing with a developer workflow and offering consumption-based, a scalable model for running application code. And I kind of would add to that, a growth in the amount of managed services that I see from the big cloud providers falls into this kind of cloud native serverless offering as well. And then if I think about the real recent past, a lot of the serverless offerings are looking at how they abstract on top of Kubernetes. Okay, so a rapidly growing platform for application hosting has its own set of complexities. You see projects like Knative and Kubeless trying to offer that serverless experience on top of a particular deployment platform. Really today we're going to be focusing on this bottom layer. But if you think about all of these platforms, they offer scalability, availability, simplicity, and ideally the ability to work with just your application code. So how does Terraform fit? I'm going to assume that everyone here has some base knowledge of what Terraform is and what it does. All that I want to say is, at HashiCorp, we focus on workflows over technology. Terraform is a tool that gives you a repeatable automated workflow for managing a lot of the supporting elements for your application. And we do that using code. And, I think that's a really important point for this session. Okay, we're talking about infrastructure processes that are typically GUI-based, ClickOps style, and it's based on knowledge that lives inside an operations person's head, or maybe lives in a 50-step wiki somewhere. And we're taking all of that knowledge and it becomes codified. Once that's codified, suddenly all of these supporting elements can be managed, tested, iterated on, collaborated on in the same way that you're used to working with application code. On top of that, Terraform has great vendor and community support. So that kind of means that you can apply this consistent automated workflow to manage almost anything that you would want to do on the public cloud, a lot of things that you want to do in SaaS environments, and a lot of things that you'd want to do in a more traditional on-prem environment as well. So I've just got some examples here. Okay, this is not exhaustive, right? But some examples of from our documentation on support for some serverless resources. So we've got AWS on the left, Azure in the middle, and Ali Cloud on the right-hand side. So, that's one thing to think about, is this kind of large breadth of support for the different cloud services. And if we think about AWS, I also want to focus on, if we think about what we call the AWS provider, so how Terraform interacts with AWS, we have 1,600 contributors to that provider alone. So there's a lot of depth of support in there as well. And that means, think of things like new features, bug fixes. With a large community, they can become quite quick and reliable. So I do want to sort of use AWS as an example and zoom in on how you would use AWS Lambda and just give you a bit of a feel for what Terraform is doing. So let's say we have an AWS environment, we have some code we'd like to host via Lambda. We already know Terraform can create the Lambda object for us, but this doesn't really do anything on its own, right? So you need to think about how we're going to invoke that function, expose it via an API, or use one of Amazon's messaging services. There's the question of storage. Where does my code live? Okay, if there's anything stateful about this function, maybe it needs to store things on EFS. Maybe I want to consume other AWS services as well. Put this in a VPC, use KMS to do encryption for certain data with that application. And then definitely if you're thinking about production, you want to plug the whole thing into CloudWatch and use IAM to connect it all together. So you've now got 8 supporting elements for a single Lambda function. And this is really where Terraform shines, right? So knowing how to set this up via a GUI or to automate this yourself has a few challenges. First, you'd have to know the order of operations, have to know the dependencies between these services, right? Does the API gateway depend on the Lambda function, or is it the other way around? Terraform works out these dependencies for you, so all you need to worry about in your code is the desired end state. Terraform also simplifies the data handling between these services. So for instance, connecting IAM to your Lambda function becomes very simple. The second challenge is around lifecycle. So if I was to automate this myself, I can write some Python, I'd probably have something working fairly quickly, but you can bet that that script would only create these resources, right? How would I handle any changes to the code, any changes to the infrastructure or the environment? How would I remove a particular element? Then how do I make that code repeatable? How do I make it usable by other operators? Terraform takes care of all these kind of lifecycle operations for you, and I'll show you that once we get to the demo. And really the outcome is you can get started quicker, and it also means that you're going to get into production with a lot more confidence using Terraform to tie these together. I do want to point out, we looked there at interacting with all of the required resources with Terraform. There is another way to think about this, which is using modules. So I do have a module here that was that's written by one of our big community contributors. And modules really take a lot of those underlying resources and maybe they code them with same defaults, right? Or maybe they combine a lot of those underlying resources together into a single package. For example, this module on screen, you can see exposes a name, a description, a runtime. It's all fairly simple. But there might be a lot of the options that you have for configuring Lambda that are taken care of kind of under the covers. The other interesting thing about this module is it actually takes care of the application packaging for you as well. So this module will actually use some commands on the local machine to package up your function and get it ready to be consumed by Lambda. So I'd encourage you, go and check out modules like this one. You can have a little search around and you'll find a lot of them out there. So what I want to show you today is an example pattern for working with Terraform for serverless. And, we've spoken a bit about, I think, the tools so far and what's possible. I really want to focus on the workflow, right? How does Terraform fit into some of your existing workflows? And since we are talking about serverless, it's all about application code. We're really going to try and fit into an application code workflow. So it's all going to start with version control, which today will be GitHub. I have a bunch of code in GitHub, some for my application and some that describes the Terraform environment that I need to support that application. My version control is connected to a CI/CD platform. In this case, it's BuildKite. BuildKite is going to be our kind of master orchestrator for the process of getting our application onto Lambda. BuildKite is going to interact with Terraform. Terraform, in the first step, is going to create an S3 bucket to hold our code. BuildKite then uploads the code into that S3 bucket. We then have a step where Terraform creates all of the other resources that we need to create the Lambda function. Okay, so that's what we're going to see. I'm going to step through it very quickly in the time that we have left. So to explain what we've got on the screen, the right-hand side here, we've got some code. We've got our application code, very simple Node.js function. We've got a bunch of Terraform code as well. I'm not going to go into the Terraform code. This is all pulled from our Learn website. So learn.hashicorp.com. Look for the Lambda tutorial on there. It has all of this code that you can step through yourself if you want to do a bit of a hello world example. So we've got all the code that we need. On the left-hand side here, we've got BuildKite. So again, our CI/CD tool, our pipeline, and a couple of tabs here on the bottom. One is Terraform Cloud. Okay, so I'm going to be interacting with Terraform Cloud instead of Terraform Open Source, and I'll talk through a few of the differences there. You can also see our AWS console. We've got the Lambda service pulled up, and there's nothing sitting in there at the moment. So I'm going to make a change to our code. Save this. Okay, so our code is hooked up to version control. Stage that change. I can commit, and I'm going to push that to my remote repository that lives in GitHub. I've hooked up my CI/CD pipeline to watch for any pushes into GitHub. Now, obviously in production, you'd probably have some kind of pull request, a system of doing branching or merging that we're not going to do here. We're just doing a straight push, and you can see that that's kicked off our pipeline. Now, the first step here was looking at the supporting S3 bucket for this application. And you can see that Terraform has started a planning stage here. Now, I kind of want to point out, we're speaking about resource lifecycle. So our S3 bucket is something that exists already. This is something that is long-lived. The nice thing about how we can interact with the Terraform Cloud API is we can do a check and say to Terraform, okay, we need a bucket, okay, that supports this application. I need to check with you, does this bucket exist? Does it match the desired state? Now, what we can see from the code, if I close this, is here's my bucket code. So this is what I've decided is the desired state. It just defines a fairly simple bucket. And what we can see from BuildKite is that there was nothing to change. So again, this is not just about instantiating or creating resources. You might have a resource that exists already and you just want to make sure that it's there ready to receive. And from Build Kite's point of view, no change from Terraform means that we can step through to the next step, which was the upload. So BuildKite has taken my Node.js code, zipped it up, and uploaded it into my S3 bucket with a version tag, which I'll get to later. We've then done a plan stage. Now, I'm just going to very quickly approve this, just so we can fast forward time a little bit. But let's take a look at that plan stage. So BuildKite then had a stage that said, okay, we've now got our bucket, we've got the code in the bucket. There's now a bunch of Terraform code that describes all of the Lambda and other resources that we need to make this a reality. Terraform has gone and run a plan. So it said, okay, the desired state is to create all of these Lambda resources. We know that there was nothing existing in AWS already. Here's what needs to change for us to get to the desired state. And it's given back a whole bunch of resources that are going to be created that I could look through and say, okay, yep, that all looks fine. Okay, 10 new things are being added. And then I had a little approve stage there. Once I've done my approval, Terraform now takes that plan and can go and instantiate the infrastructure. So I've seen that's been a success as well. We can see here from line 52, Terraform actually interacting with the AWS API for us. And we've got a nice output here. Which points to my code running on a Lambda function. Now that's creation, right? So this is something, again, that I could have probably very easily done myself with some automation. What if I wanted to make a change? I'll quickly step through this again. And what we should see in a second is that that push is going to kick off another change within BuildKite. Now, the nice thing about this is Terraform is idempotent. So Terraform knows that, okay, if nothing has changed within my desired state, there aren't any changes that need to take place on the infrastructure side. Now, we haven't had a change here. Let's have a quick look. Oh, you know what I didn't do? I mentioned the code version variable earlier. So this is one way that we can tell our build pipeline and tell Terraform that there's a change that we expect. So I'm going to change this. I don't know why that's kicked off. Let's do it manually for now. Maybe a network issue on my end. So what's going to happen right here is that Terraform again is going to do our bucket check. Now, again, this is a long-lived resource, so I wouldn't expect anything to change. What will be interesting is once we get into the workspace, because if we look in our AWS console, we're going to see that we have our Lambda function already. We also have all of the API gateway resources that exist already. So what we'll see from Terraform, hopefully we'll get there, I know we're getting short on time, we'll see that Terraform knows that there are particular parts of these resources that need to be recreated, particular resources that need to be just changed. And it's going to make those small changes for us without having to recreate the whole environment all over again. Okay, so our upload is good. You can see here that our variable has fed through. We've now got a new path on S3. And this will be the last thing I show, and then we'll finish up. One thing that I want to point out just with Terraform Cloud compared to working with the regular Terraform is, number one, you'll see here that it's centralized and it's behind a GUI, right? So it's kind of one of the things I like about Terraform Cloud is it gives you some flexibility as to how you interact with Terraform. So I can have Terraform code that I connect up via a Git repo, for instance, in this workspace here. I can have other Terraform code that I interact purely via API. So for instance, with my build kite pipeline up above. Okay, this is what I wanted to show. Okay, so Lifecycle. Okay, so Terraform can see that we are changing a particular value for our API gateway deployment. Terraform has a notion of lifecycle. So what it's going to do is it's going to create a replacement for this API gateway deployment. So it's not the gateway itself, it's just a deployment. It's going to create a replacement and then it's going to destroy the original. And it also knows that our actual Lambda function has to change. And there's a line here, yep. So the S3 key, so where we're pointing our Lambda function to find the code needs to change. However, this is a change that can be made in place. So we can see here that Terraform is just going to do that as a very quick update. We probably don't have time to run through that all. Again, that code is available. I'm going to make this repo available as well for anyone that wants to step through this on their own. But the nice thing about this is we would just get a new URL back at the end, points to the new version of our app, and our app has been kind of rolled forward, and all of the infrastructure supporting that is part of the same repository, the same pipeline. We get a single view on that application really as a package. Okay, so if you've liked what you've seen, if you want to know more, please head to terraform.io. All of our documentation is there, whether you're using the open source, using the CLI, whether you want to use the API, the documentation is there. You can also sign up for Terraform Cloud. It's free to get started. I'd really recommend it, especially if you're looking at interacting via some kind of CI/CD tools, or you're looking at how to fit this into workflows that you have already. And again, learn.hashicorp.com as well, great resource to get started with something like Terraform, and all of the code for that Lambda example lives on there as well. And that's it. Thank you very much for your time, and I'll hand back to Pete.
Awesome. Thank you, Dan. That was some great presentation. Very nice work. I was just looking in the Q&A to see if there's any questions, but it looks like David Wright's on it, and he's answered most of those questions there, which is good. Yeah, well, folks, as Dan mentioned, that brings us to the end of our session today. As I mentioned at the top of the call, this session was recorded, and I'll be making a link available to you all via an email, so you can go back and watch what you might have missed, or just to get a recap. And as Dan said, if you like what you heard today and want to learn more, we encourage you to visit our Learn pages on learn.hashicorp.com. And don't forget to tune into our future snapshots. The next one coming up is on securing your CI pipeline with Vault, which will be held on the 8th of September. And you can register at hashicorp.com/events/#snapshots as it shows on your screen there. And if you've got any questions for Dan, feel free to reach out on that very simple email there of dk@hashicorp.com if you've got any questions. Until the next time, thanks again for joining, everyone. And I'm closing it out now. So bye for now. Thanks again, Dan.
Thanks, guys.